Today we're going to be talking about segments, rays, and distance. So yesterday we talked about lines, and I have a picture of a line on there. Now a segment is a part of a line that has two endpoints. So I have on here segment DL, and how we denote that it's a segment versus a line is we draw a little line above it. Another one would be LS. Another one would be DS, where again we're naming it by the endpoints with a little line above. Now just so you guys know, DS and SD are the same segment. When we're actually talking about the distance or the length of this segment, we have DL, LS with no bar across, and then obviously SD or DS. Now a ray is part of a line. It has an endpoint and extends infinitely in one direction. So LS would be an example of a ray. We put the endpoint first and then any other point on the ray, and we put a little ray symbol above it. We always start with the endpoint, and the ray is always facing to the right. Now LS, and let's look at ray SL. Well, ray SL, the endpoint is S and extends the opposite direction. Even though it extends the opposite direction, we still put the ray symbol above going to the right. Those are two different rays because they're going in different directions. And there's a bunch of other rays on there. Another ray we could name would be DL. And DS technically would be the same ray because L and S are on the same side of D, and D is our endpoint of that ray. Now, opposite rays. Opposite rays are two rays that share the same endpoint. So an opposite ray here would be LS and LD. So when I have two rays together, what we have is we have a whole line. Find the length of each one of those segments. How we can find the length of a segment is we take the absolute value of the difference of the endpoints. So CS. So I'm going to do 7 minus a negative 9 to get me 16. AT, the absolute value of 4 minus a negative 3 gets me 7. CT, 4 minus a negative 9 to get me 13. And TS, say I wanted to do 4 minus 7. Well, we know that's negative 3, but absolute value turns that into a positive 3. Remember, absolute values talk about distance. That's why it is used when we're finding the length. Okay, now we have some postulates. A postulate, this is a definition, is a statement that is accepted without proof. Now, geometry is based on proving different theorems. Now, a theorem is a statement that has been proven, and we're going to get to those later on, but a postulate is accepted without any proof. And we have our first postulate, and it's a little bit of a wordy one. So there's two parts to it. The first part is that points on a line can be paired with any real numbers in such a way that any 2 points have coordinates 0 and 1. So what that means is we have a number line. I can name any points 0 and 1. And then I can put little things in between. Well, that's going to be each one of those is going to be 1/6 of that whole segment. But maybe to make our lives a little bit easier, what we could do sometimes by our ruler postulate is say that instead of that being 1, we're going to name that 6. So now we're just dealing with integers. So that's basically what the ruler postulate, the first part, is. The second part is what we just did. That it has, once a coordinate system is chosen, so once I've picked my basically scale on our number line, the distance between the 2 points equals the absolute value of the difference of their coordinates. So that's what we just did in the last example. Okay, now again, lots of definitions in this chapter. So our first definition, congruent. Two objects are congruent if they have the same size and shape. In geometry, we're going to be proving triangles congruent. That's one of the major things that we do. So that means they have the same size and same shape. Now, congruent segments are segments that have the same length. Let's talk about how we would mark up our diagram. So if I have a segment, and say that segment AB, and this is the notation for it that I expect you guys to know, is congruent to segment BC, so that means AB is congruent to BC, how we would mark that. Even though it doesn't look like it from my diagram, we can mark up our diagram and say, well, that and that are equal. But say that these were also congruent, and I'm going to add in another one here. I'm going to add in another point, E. Say that was also congruent to DE. Then I would also mark that segment with one marking. Now say CD was congruent to some other segment, I would start and mark that with two markings. Midpoint is a point that divides the segment into two congruent segments. So technically, if we look at this, segment AC, B is the midpoint because we've broken it up into two congruent segments. Now, a bisector is a line, segment, ray, or plane, so anything that's going to bisect a segment at its midpoint. Another postulate, and we're going to be using this postulate a lot. So you have two options when we're using this postulate in proofs. You can write out the whole name, segment addition postulate. We gave it a name. Or you can use our abbreviation. And throughout the year, I'm going to be giving us a lot of common abbreviations. If I forget to give you an abbreviation, just let me know. So we have, if B is between A and C, so let's talk about what that means. Point B is between A and C. So it's somewhere in between. And notice how it doesn't have to be in the middle, and I kind of exaggerated that for you. Segment AB plus segment BC equals AC, our whole segment. So an example involving that. L is between D and S. DL is 3x plus 6, LS is 9x minus 2, and DS is 40. Find the length of LS, and is LS the midpoint of DS? So we have two questions there, and my high school geometry teacher always made sure we answered the question. So first you want to draw a picture. That's the first thing I'm going to be asking you guys. Did you draw a picture? So L is between D and S. So L is somewhere in here. I don't know what it looks like. I may need to readjust my picture eventually. Now label your picture. DL is 3x plus 6. LS, 9x minus 2. And the whole segment is 40. So to find the length of LS, I need to solve for x. So set up an equation. 3x plus 6 plus, because DL plus LS equals the whole segment. LS is 9x minus 2. That equals the whole length of DS. Well, that guy's 40. So now we combine like terms. 12x plus 4 equals 40. Subtract. And divide. So I get x to be 3. Now let's plug in 3 for x to determine what the length of LS is. Now if LS is 20, then we know L is the midpoint, because They would have to be equal segments, so that's half of 40. 9 times 3 minus 2, well, that's 27 minus 2, that's 25. So no, L is not the midpoint. Let me make that S look a little bit better for you guys. So we've answered all the questions. We've have it, LS, you might want to write it out for me, is 25. Okay, so again, make sure you're answering the question. Solving for X is not enough in this case. There are your 2 lesson questions. You don't have to draw the picture on the Google Doc because that's going to be hard, but make sure you have that drawn in your notes.